All right. So as we look at this, we recognize that this one can be written as, how would you write that? X plus 4, and then all of it squared. Okay. The last one also we recognize could be written as what? Okay, x minus 3, actually z, sorry. Z minus 3. Oh, I see I did x's and z's. I see. All right. Okay, z minus 3 squared. Sorry about that. Those should have all been consistent. But you told me that these guys here could not be written that way, right? Okay. So, can they be factored at all? Can the first one be factored at all? Can it be factored like this? Remember, not everything is factorable. But is this one? You got to multiply to get negative 6, add to get positive 1. How about minus 2 plus 3? Okay, that one does work. What about this y one? Other than the fact that I have an x and a y mixed up. That was supposed to be a y there. 3 and 1, so y plus 1, y plus 3. Okay, so these two are factorable, but are they perfect squares? No, okay. And really, that's all I wanted to know was, were they perfect squares? So the answer is no. Those are not perfect squares, okay? Which means I don't even want to think about them anymore. They're gone. I just want to pay attention to the perfect square ones, okay? So let's think about how we came up with these answers here. How did you know that was a 4? 4 times 4 does give you 16. But 2 times 8, there's other things that give you 16.
4 plus 4 gives you 8.
Okay, 4 plus 4 gives you 8, and 4 times 4 gives you 16. All right, what about over here? Okay, negative 3 times negative 3 does give you 9. And negative 3 plus negative 3 gives you 6. Now, I like all of those answers. Those are great. I just want to rephrase exactly what you said. Instead of saying 4 times 4, I'm going to say 4 squared. Okay? And instead of saying 4 plus 4, is it fair for me to say 4 times 2? All right. So, this works because 4 squared is 16, but 4 times 2 will give you 8, right? And over here, negative 3 squared gives you 9, but negative 3 times 2 gives you negative 6. Is that fair? All right, well, let's put our puzzle thinking caps on. What has to go in this blank down here? Think about the patterns we just established. 25. Most people would say 25 with no hesitation. Let's make sure we can figure out the pattern. Why? We're not going to talk about the pattern just yet.
5 times 2.
Okay. What about the second one? Okay, I think we're still good with the pattern here. Maybe I lost a couple people. But here's where we're going to see if we have a pattern or not. Raise your hand if you think you can fill in this last blank on the top row. What goes in this blank on the top row? You need to go back and think about how you came up with the 1, how you came up with the 25, how these two problems up here worked. Who's got an idea of what I could put in here to make this work? All right, it is 6.25. Okay, actually, I don't like that particular answer, but it is right. Okay, how'd you get it? Okay, so you said 5 divided by 2, and then you squared it. Now, why did you do that? Does that mean over here you did the same thing? Yes, you did. Let's check out over here with the 10 and see if the same process that she just used works. She said take the 10, divide it by 2, gives you 5, and then square that answer, and that's what goes in that slot. Does it work? Yes, try it on this one. Take this 2, divide it by 2, and then square it. Does that go there? Yes. Go back up to the top. Even though these were a different order, see if it still worked. What if I took this 8 right here? What if I took that 8 and divided it by 2 and then squared it? Would it give me 16?
Yeah.
Yes, it does. And what about over here? If I take this negative 6, divide it by 2, and then square it, does it give me the 9? So far it worked on these 4 examples, and I'm telling Nikki she's right over here. So she says take negative 5, divide it by 2, and square it. And she's right, it is 6.25, although, if you don't mind, I would rather write it as 25 over 4. Even though they're the same thing. Okay? So, that's fantastic. Now you can force something to be a perfect square. Try another one. Try this guy down here. What has to go in this blank to force this to be a perfect square? It'd be 9 over 2. And then square that. 9 over 2. You know what? I'm not going to use the decimal. I'm just going to go 81 fourths. Or its decimal equivalent if you choose. Does that make sense? That's the process. That is what we call right here completing the square. That is the name of what we're doing. Is completing the square. You take something that is not perfect. This was not perfect. And you force it to be perfect by figuring out what missing piece would make it perfect. Okay? So if we put a 25 here, then this becomes a perfect square trinomial. If we put a 1 here, this becomes a perfect square trinomial. All right? Hey, 2 more. They got fractions and decimals. Let's check them out. How would I go about the process here on this x squared minus 4/5 x? Okay, I'm still going to divide it by 2. So I've got 4/5 divided by 2. And then I'm going to square that. 4/5 divided by 2 is 2/5, right? And then 2/5 squared becomes 4 over 25. And then over here, with the decimal 1.6, same idea. What do we got? 1.6 divided by 2 becomes 0.8. And 0.8 to the second power is 0.64. Why would I write this as a decimal when I did the others as fractions? Yeah, there's a decimal in the problem, keep them decimals. If there's a fraction in the problem, keep them fractions. If there's neither, then you can use either one you want to, but honestly, the fractions tend to make more sense as far as patterns go. I'm going to try to factor the first one just to see, because hey, you know what? It's equal to 0. If I can factor it, then I can use the zero product property, can I? So the question is, what will multiply to give you 4, but at the same time add to give you 6? And the answer to that, of course, is nothing. None of that works, does it? So if none of that works, what am I going to do? I can't factor it, which means I can't use the zero product property there. Okay? Well, last night we were doing all those square roots. Is this a perfect square? No, it's not. If it were a perfect square, I could have factored it. But I can't. It's not a perfect square. So what am I going to do? All right, I heard somebody, Nikki maybe, she said subtract 4. The 4 is the problem. This 4 is keeping this from being a perfect square. So get rid of it. I'm going to subtract it. That leaves me with x squared plus 6x. I'm going to leave a little space there. Equals negative 4. Why'd I leave a little space? Because I'm going to force this to be a perfect square now. I'm going to complete the square like those last 6 problems. And I'm going to force this to be a perfect square. What number can I put right here that would force this to be a perfect square? It'd be a 9. Right? I take half of 6 is 3. 3 squared is 9. So I'm going to add 9 right there. And thank you very much. Golden rule of algebra. If you do something to one side, you do it to both. So if I add 9 to one, I add 9 to both sides. Simplify what you got. Well, what I have here is a perfect square. That was the whole point of doing that, right? Was to make it look like a square. And of course, on the other side, I have a 5. Now, is this last night's problem? Sure it is. If you have something squared, you can do the inverse of the square to solve it. What's the inverse of the square? Square root both sides. The square root and the square are inverses. They'll cancel each other out, and I'm left with x plus 3 equals plus or minus square root 5. Finish solving. Subtract the 3, right? And that gives me x equals negative 3 plus or minus the square root of 5. And of course that is 2 different answers here. I've got negative 3 plus the square root of 5. That will give me some decimal answer. And I also have negative 3 minus the square root of 5, which would give me a different decimal answer. But like I said, I'd rather just not have decimal answers at all. So we'd stop right there. There's our solution. Okay. Once again, you can try factoring this. I mean, it'd be great if it factored, right? Zero product property, real easy to solve. But does this factor? No, nothing's going to multiply to give me negative 10. That will also add to give me 5. So it is not factorable. Well, if it's not factorable, then clearly it's not a perfect square either. But let's force it to be a perfect square. Let's get rid of the 10. And that'll leave me with x squared plus 5x. Leave a little space equals 10. Now I leave the space here because I'm getting ready to force this to be a perfect square. How do you force this right here to be a perfect square? Alright, I need to take 5 divided by 2 and then square it, and that's what's going to go there. Does that make sense now? Which is 25 over 4, or you can do 6.25, whichever way you want to. I think I'll just leave it as 25 over 4. And if you add it to one side, got to add it to the other. So I'm going to add 25 over 4 on this side too. Now I kind of wish I did 6.25. Alright. Anyways, the reason that I did that was because now this is perfect. This is now perfect. So that's going to be x plus, what's it going to be? 5 over 2, right? 5 over 2 squared equals, what is that? 16.25. 16 point, I don't know. Do you want to switch that? If I've got a fraction here, I should really have a fraction here. 65 over 4. All right. And then finish solving. Square root, square root. X plus 5 halves equals whatever the square root of this is, which actually we would really be in good shape on this technically. It's not written very well. If we'd have finished studying, we actually, don't we know what the square root of 4 is? You could actually change this right now to square root 65 over 2. All right? Which I guess we might as well do, even though we really haven't practiced with radicals very much. But that's the same thing as plus or minus square root 65 on top. But the 2 is not under the square root sign anymore, is it? Okay? And again, we haven't really practiced enough with that, but if we're worried about the practice part, then you can just leave it like this until we get to the end of the problem. It'll be fine. You do have one more step. What's that going to be? Minus the 5/2 here and here. And I'm totally out of room, so I'm going to write this at the top. That my answer would be x equals negative 5 over 2 plus or minus square root 65 over 2, which is actually pretty nice because now I got common denominators. I could even put those together, couldn't I? X equals negative 5 plus or minus square root 65 all over 2.